Good morning. We're going to solve this problem. We use the vector diagram to solve this problem. Now we are going to use complex numbers. As you see, vector diagram, it's a little bit complicated and we had to draw, but now we are going to use complex numbers to solve this problem. So I will explain what we have to do here. I think this circuit draws an RMS current of 10 amps at a lagging power factor and dissipates a power of 2 kilowatts when the voltmeters V1 and V2 each indicate 250 volt RMS. Calculate the power factor, cosine phi, power factor, the power dissipated in R, PR1, R1, the values of XC, R1 and XL. Okay, I think here there are three methods of writing the complex number. For example, for voltage we can write it as real value plus J, the imaginary value. Or we can write it, this way is good for Kirchhoff's law, when we have to add voltages. But when we have to multiply, the case, for example, for Ohm's law, where we have to divide and multiply, it's better to write this way in a form, the module and argument. We can write it this way, V and the argument, where V is the module, it's square root of Vx squared plus Vy squared. Theta is arctangent of Vy over Vx. This is another way of writing. This is good for Ohm's law. The third way is that will help us to go from this form to this form, or vice versa. It's this form where we can use cosine theta plus J V sinus theta. This form will help us to calculate Vx and Vy. Okay, let's start. Well, I can tell you exactly how to do it. First thing is, this is lagging, so we know we can calculate power factor, because we know the total power is 2000 watt. We know that V1 is 25, V1 is equal to V2 is equal to 150 volts. This circuit draws a current of 10 amps, so we can calculate cosine phi, sine phi, and then we can write I in complex form, and then we can calculate V2, and when we have V2 we can calculate V3. From V3 we can calculate I2, I1, PR1 and the rest. So step by step, cosine phi we can calculate it is P over the apparent power. This is 2000, S is VI and V1I, and this is 2500 and 0.8. Cosine phi is 0.8, and sine phi should be equal to 0.6. Okay, 0.8. So we can write that the current in complex form, because it's lagging, this current is 10 arc. This angle is 36. I calculated before. It's 7 degrees. We can calculate it again to check. 3687. Okay. Or minus, because it's lagging. Minus. Let's take another color because it's fading here. Or we can write it in this form, amps. Okay, now we can go this way, because we know the current, we know the voltage. We can calculate Z2. If we call it Z2 is equal to V2 over I. It's 250 divided by 10 is 25 ohms. We can calculate from here, we can calculate XC is equal to Z2 squared minus R squared, which is equals 15. This is 25 squared minus 15 squared, and this is 20 ohms. So we write here 20 ohms. First, same time we can calculate the instantaneous currents, voltages, V1, V2, V3. This one we have it, it's 10 square root of 2 sine omega t minus 3687 degrees. The V1 we know it as well, 250 sine omega t. This is the reference. Okay, now X we calculated. Okay, so we can say that we have Z2, we can write it in a complex form. Z2 is equal to 15 minus G20, or 25 and 53, I think, minus 53, 13 degrees. Okay, we can now calculate V2. V2 is equal to Z2 times I, and Z2 is here, 25 minus 53, 13 times the current, 10 minus 36, 87, and this is 250, 90 degrees, minus 90 degrees. Okay, we write V2 here so that we don't forget it. Minus 90 degrees. So we can now calculate V3. So we can write the result here, 250 square root of 2 sine omega t minus 90 degrees. Okay, V3, Kirchhoff's law, V1 is equal to V3 plus V2. V3 is equal to V1 minus V2. V1 is 250 plus J0 minus V2, which is equal to minus J250, and this is 250 plus J250, and it's 250 square root of 2, and here plus 45 degrees. So V3 we can write it as 500 sine omega t plus 45 degrees. I write it here so to remember it. 250 square root of 2 plus 45 degrees. Now we can calculate I2. I2 we can calculate it is V3 over J50 and is equal to 150 square root of 2 over 50. This is 90 degrees, this is 45 degrees, and I2 is 5 square root of 2 minus 45 degrees. I2 we can write it here. This is 10 sine omega t minus 45 degrees. Okay, now we have I2. I'll write it here so that I don't forget it. Minus 45 degrees. Okay, now using Kirchhoff's law we can calculate I1. I is equal to I1 plus I2 complex form, and we need I1. I1 is I minus I2. I we have it where we have it here. 8 minus is 6 minus I2. I2 we can write it 5 square root of 2 times 1 over square root of 2 minus J1 over square root of 2, and this is 8 minus J6 minus 5 plus J5, and this is 3 minus J, and this is 3, 16 minus 18, 43 I think degrees. So we write I1 here so that we have all the forms. I think we need the second form, 316 minus 18, 43 degrees. Now we can calculate what left PR1, R1 and XL. We can calculate the apparent power here. So this is V3 times the conjugate of I1. V3 we have it here, 250 square root of 2 plus 45 degrees times the conjugate 316, 3.16 plus 1843. This is the square root of 2 times 250 times 316. This is 1017. I will do it again because 250 times 316 times square root of 2 is equal 17.229, and this is the apparent power, and the angle is 63, I think 63, 18.43 plus 45, 43. We can calculate cosinus phi1. This is 0.4473, and sine phi1 sine 0.8944. From this we can calculate P1. P1 is this one times this one is 500 watt, and plus this one times this one is 1000. This is Q1, this is P1, PR1, what we call 500. You can write here 500 watt. And we are left with this. TR1 is R1 I1 squared. R1 is PR1 over I1 squared. This is 500 over 316 squared. This is about 10. So this is 50 ohms. 50 ohms. And Excel, we go to Q1. Q1 is XL times I1 squared. XL is QL over I1 squared. 1000 over 316 squared. And this is 100 ohms. So we calculated everything. We're left with I1. I calculated here. It was 316 square root of 2 square root of 2 sine omega t minus 1843 degrees. And that's it. You see, we didn't have to draw anything, and I think it's easier to proceed this way. And thank you very much.